Hey everyone, if you're building across multiple clouds, you already know the deal. Trying to create a realistic test environment can get super complex, and wow, can it get expensive. So today, we're going to lay out a blueprint for a much smarter way to do things.
So let me ask you this. Does looking at your monthly cloud bill for your staging environments just make you wince? Yeah, you're not alone. It feels like this constant battle, right? You need high-fidelity testing, but you've got a budget that's always under pressure. It can seem like a totally impossible trade-off. But what if the problem isn't really your budget? What if it's your entire approach? Okay, let's dive right into the root of the issue. We call it the production mirror trap. It's this default instinct that so many engineering teams have. Let's just build a perfect one-to-one copy of our production environment for testing. And look, it seems logical on the surface, but in reality, it leads to just astronomical costs, painfully slow deployments, and as we're about to see, it's often completely unnecessary. So this brings us to a really fundamental shift in thinking. We need to move away from trying to build a full replica and instead focus on building a realistic model. See the difference? This isn't about a perfect identical copy. It's about a smart, functional representation that actually serves our testing needs without all the bloat. This slide really lays out the two paths you can take. You've got the old way, the full replica, which, let's be honest, means sky-high costs and deployments that just crawl, taking forever to spin up. And then you have the smart way, the realistic model, and this is all about efficiency. You get way lower costs, you get faster feedback for your developers, and you end up with a much more focused, effective testing strategy. Let's really break this down, because it's important. Functionally accurate. That means we care about how the services behave and interact, not that they're running on the exact same oversized, expensive server as production. And captures production patterns? Well, that just means we're focused on simulating the real-world data flows between our services. That's where the real value in testing is, right? So, building this realistic model really rests on two main pillars. The very first one is all about your test data. You know, it's the fuel for your entire environment, but getting it right is often one of the biggest headaches. Just think about it for a second. Simply cloning your production database? It's a total nightmare. First, the sheer volume. I mean, we could be talking terabytes, even petabytes of data. It's incredibly slow and expensive just to copy. Second, it's a massive security risk. Your production data has sensitive customer info that has absolutely no business being in a lower environment. And finally, you have to somehow maintain all the data relationships, making sure everything still connects properly, which is just wildly complex. So, the smart solution is basically a three-step process. First, data subsetting. You just take a small but very representative slice of that production data. Second, you anonymize it. You scrub out all the personally identifiable information. And third, especially for testing new features, you can use synthetic data generation to create realistic-looking but totally fake data from scratch. You get all the realism you need with none of the risk. All right, on to our second pillar, the network. In any multi-cloud setup, network connectivity is just this tangled web of complexity and cost. Our goal here is exactly the same as with data. We want to replicate the essential pathways, not the entire expensive infrastructure. You know, just trying to copy the production network is often impossible. You have all this complex routing going on between different cloud providers, you need to simulate latency realistically, and then you have the incredibly high cost of things like dedicated interconnects or VPN tunnels that you'd have to duplicate just for testing. It is another massive budget killer. So the key technique to solve this whole networking mess is something called service mocking. A mock is basically a lightweight stand-in, like a stunt double for a real service. So instead of running a whole complex application, you create this simple substitute that just provides the exact responses your service needs to see, like a 200 OK or a 404 not found. It's an incredibly powerful way to isolate components and test how they interact in a predictable way. Now, the strategy is to apply mocking intelligently. You don't just mock everything. For non-critical dependencies or maybe some stable third-party APIs, a service mock is perfect. But for the core services that absolutely have to talk to each other, you establish simplified, direct communication paths. This gives you that high-fidelity interaction where it really counts, and high efficiency absolutely everywhere else.
All right, enough theory. Let's stop talking in the abstract and actually look at how this blueprint works in practice. We're going to use a really common example, a multi-cloud retail application.
So, check out this design. Our user authentication service, it runs on Cloud A. That's critical, so in staging, we deploy a real, just scaled-down version. The product catalog, it lives on Cloud B. Same story, we need that real interaction. But now look at the payment gateway. That's a third-party service. Do we really need to make real API calls to it every single time we test in staging? Absolutely not. We use a service mock. It simulates success and failure responses, letting us test our checkout flow perfectly without any of the cost or complexity.
So what's the end result of this kind of intelligent design? Well, how does this sound? We have seen teams achieve cost reductions of up to 85% compared to a full production mirror. That is not a typo. 85%. That is the kind of financial power we're talking about when you move from a replica to a realistic model.
And honestly, the benefits go way beyond just saving money. Because these environments are smaller and simpler, they lead to much faster development cycles. Your teams aren't stuck waiting around for days just to get a test environment. And this increased testing velocity and accuracy means you catch more issues early on, which results in fewer bugs ever making it to production. It's a trifecta of wins. It's cheaper, it's faster, and the quality is higher.
So as we wrap up, I want you to think about your own projects. What is the one service you could mock? Or the one massive data set you could subset? Or the one network link you could simplify that would make a real impact, like right away? The blueprint is right here. The next step is just finding that first place to apply it. Thanks for watching.